Welcome to all. This is part 8 of analysis of doubly reinforced rectangular section by limit state method. See, actually part 7, if you remember, we performed trial and error procedure. But second trial only we got the answer. Now, question number 2, this is camera mark, don't see this one. Question number 2. 2 stands for torch steel. C means third question. Note, it is master question. For completely understanding flexural analysis means finding ultimate moment of resistance, short form UMR of given cross section, given doubly reinforced rectangular section, we are doing by limit state method. And further note, by trial and error means doubly reinforced section by limit state method analysis is always by trial and error, which is the correct method. Class, only for information. If somebody will do by some other approach without trial and error, I will tell it is wrong. That's all I can tell. If they are not performing trial and error, it is 100% wrong. That's my final judgment. Okay, now one more important. This question I will thoroughly cover. And one more thing you write. If you go through this question correctly, then see, thoroughly go through the entire class and write everything. What all I write in the board and also what all I explain. Write explanation given in the class, right? Then you will get complete grip on this analysis of doubly reinforced section by limit state method. So completely you have to go through the class and everything you understand. And one more thing, if this question is fully clear, all the previous questions are clear. So once you go through thoroughly and understand and make note, writing everything, a pakka fair copy required, then previous questions you can understand very easily. So that's why everything I wrote once again here. See, I am changing the usual pattern today. I have not started solution. I wrote only information here. Okay, start. First question. Usually I dictate, this time I wrote here. Rectangular section of a RC beam has width of 250 mm and depth of 650 mm. Width 250, overall depth 650. Depth means always overall depth. Sometimes they give depth to center of steel, tension steel. That means they are giving effective depth. They will tell at that time. If it is not given, depth means overall depth. Okay. It is reinforced on tension side by 3 bars of 25 mm diameter at a clear cover of 45 mm and on compression side by 2 bars of 20 mm diameter at a clear cover of 40 mm. Now, which side compression, which side tension depends on whether BM is sagging or hogging. Nothing given, so we will assume sagging. It hardly matters. This all I explained so many times. Once you put the sketch here and write all the basic data, then we are not referring the sketch. We are not even seeing what is the meaning of each term. Okay, therefore, I will take sagging, top compression, bottom tension, assumed. So, tension steel is this one, 3 of 25, compression 2 of 20, tension steel, if clear cover, see clear cover given 45, compression clear cover given 40. Now, that's all, start. Systematic. Now, first do one thing, solution. Write the given cross section part. Actually, you should write it here. You write, don't write this way. Once you write this one, then go further. Don't write left side. Okay, first you write this one neatly. Then go further. Everything, breadth B, 250 mm, effective depth D, from extreme compression edge, top, to center of tension steel, 650 minus 45 minus half of 25. It is 692.5. Correct answer? I think most probably. I got prepared value somewhere there. I'll check it. If wrong, I'll correct it once again. I don't have calculator here. Okay, 692.5, or we can check easily 50, 45. Okay, done. Cross-sectional area of steel in tension, AST, pi by 4 of 20, I wrote it on here. This is your AST, okay, AST. Pi by 4 of 25 square, T is not clearly visible. Actually, no problem, people know it. No point in wasting time, AST. Pi by 4 of 25 square into 3 is AST 1472.62. Area of compression steel, cross-sectional area, pi by 4 of 20 square into 2, 628.32 mm square. Effective cover to compression steel. From extreme compression edge to center of compression steel, 40 clear cover plus half of diameter 20 will give 50 millimeter. In the question they told M30 concrete, FCK 30 Newton per mm square, FP 500 steel given, FY 500, for which as per IS code, not IS code, standard, for FP 500 steel, FY is 500 Newton per mm square, and from IS code, for that, I forgot right here, is it here, for which, written here, sorry, already over. From IS code, for that one, XU max by D, 0.46, red color, required to find ultimate MR of cross section required. This is the question. First understand the question. Now what I will do is, I will remove everything now. Somewhere in the corner, which you may not be able to see, because why? I cannot waste time on calculating here. So I will calculate all the values hidden from you. Actually, was in the camera you can see up to here, I think. So you can't see anything, right? And all these numerical values, I do not want to get mixed up later. Suddenly, what is the D? What is the AST? So, what all we covered so far, some numericals, I may write in a box here. That is, I told word, already over. You don't have to write once again. Because once I rub here, see, if I got a solution in a paper prepared, I can refer. I don't have paper here. Only this pen, that's all. Therefore, I will write all data. This will be rubbed out. All values are over now. One thing forgotten, neutral axis will come here. From extreme compression, it is XU, see, green color, over. Now, ready for continuation. So, all basic data over. Now start. First step, procedure already given, systematically, explanation given, 3, 4, 5 examples are over. This is a master question, so you have to refer earlier questions. But still I am explaining so that everybody will understand. First, location of neutral axis. You are finding XU. Let XU be the depth of neutral axis from extreme compression edge, equating resultant compression force to tension force. This is a formula for XU. Those who are not knowing principles, by heart the formula. 0.36 FCK BXUE plus FSASC into FSAS equal to 0.87 FYAST. I will call a right mark here. I will tell you why. See, this equation later, if I put right means this equation or this expression. Right. Now see here, this statement you have to write. This I am writing since past 4 or 5 problems. XU depends on FSC, but FSC again depends upon XU, because if you want FSC, you require stress in compression steel. You have to find strain in compression steel. This formula, unless you know strain in compression steel, you cannot find stress in compression steel. So write FSC, XU depends on, FSC is the stress to be considered in steel in compression. Little fast I told because already over 10 times. FSC is to be obtained based on strain in steel in compression. Expression is IS code expression, double right. In future, double right. So XU depends on FSC, but FSC in turn depends on XU. See here. XU, you require FSC. FSC, you require XU. Therefore, XU is to be calculated by trial and error procedure. Now what I will do is, for a thorough understanding, as I do trial and error, somewhere outside you prepare a table, on table right here. enter the trial and error here, so that this will tell you correct idea. Table. Okay, start. Trial 1. For you have to find XU by trial 1. See, for finding XU by trial 1, you require FSC. You find that FSC for XU equal to XU max. You already know XU max by D equal to 0.46. So XU equal to 0.46 into D. Now one small problem is there. Last time when I wrote in the first round, I wrote Fy equal to 500 Newton per mm square. Therefore, XU max by D, I wrote 0.4, I should write 0.46. First I thought I will solve Fe415. So, by mistake, if I written 0.48, you change it to 0.46 because you know it. Don't make an issue or comment box. You told Fc max by D is 0.46, I am 0.48. I am telling now. When I put a basic data, see, little earlier, for Fy equal to 500 Newton per mm square from IS code, I wrote there Xu max by D equal to actually 0.46. By mistake, if I had taken Fe415 0.48 there, make it 0.46. Calculate 0.46 into D. Now, this Xu, substitute here. Epsilon SC equal to 0.0035 into whatever is the XU. See, substitute into minus D dash by XU, you get 0.00286. Now we have to find FSC for Epsilon SC 0.00286. This is thoroughly explained earlier. Make a note. Tar steel IS code figure 23A. SP16 you can use, but don't use now. From which first you get Epsilon SC at a proportionality limit 0.80 Fy by 1.15 ES formula. Get the answer. Why all I told this answer. Okay, now compare the Epsilon SC calculated. Where is it? Calculated value, that is 0.00286. Compare. It is more than proportionality limit. Personal note right here. Oh, therefore, our point lies in the curved portion. In case your Epsilon SC calculated is less than this value, then no struggling, directly Fs equal to strain into Young's modulus. Okay, over. Now, refer to IS code figure 23A. For Epsilon SC calculated 0.00286, get FSC. Okay, only once I will tell. I will rub this portion now. Only once. Now I will do one thing now. Again, same problem. For rubbing, I am not able to get that paper like one. Okay. See now, this is not required. No, not required. This I am not removing. Then even this is also not required. Now, this is also not required. I can remove, but don't write this one. Already work. See, IS code figure 23A. Briefly I will tell. A. Here mark strain of, see, this is the strain epsilon. This is the stress F, FSC, epsilon SC. Mark 0.00286 as accurately as possible. Then you can see somewhere here linear. Then see, it goes this way. Then second line is there. This is Fy. This is Fy. This is Fy. Fy by 1.15. Actually, you have to use this one. But values are not there. Use this one. Later, divide. So, you go for Fy curve. It will come somewhere here. Come this side. Either side, you can see two numbers. When I checked there, upper side number, I am seeing 0.96. Lower side number, I am seeing upper side number. I can't show it here. Upper side number, I am seeing 0.96. Lower side, 0.95. And it looks like almost midpoint. So I will write 0.955 Fy by, without forgetting, 1.15. Answer, 415.2 Newton per mm square. Make a note. Or, only once you make a note. Or, see, somewhere here I write. Or, since it is tar steel of grade Fe500, you can use SP16. Table A. Then for strains of point for Fy in SP16 for Fy equal to 500 Newton per mm square for strain of 0.00, what is our strain? 286 is, I require the values now. Where is that SP16 sheet? I kept it somewhere. I don't know where it has gone. It has gone somewhere. I don't know that loose sheet. The sheet is actually, it's here. Got it. Thank you. Strain of 0.00286 is 277, 277, and for 0.00, 277 and 312. 277 stress is FSC in Newton per mm square is 413. Other one is 423.9. Then by linear interpolation for 0.00, how much it is? 0.00, where is the answer? I told you, for 0.00286, interpolate, you will get 415.8. 415.8. This is the exact value. See, but since you are referring IS code, slight approximation 415.22. Now we will continue with IS code value only. 415.22. This also I remove now. Why? This is already explained so many times earlier. No point in wasting time on these things. Start now. I told trial 1 XU require. Now substitute here in 1 get XU. 0.36 into FCK into B into XU equal to FSC, whatever you got, into ASC, 628.82 equal to 0.87, FYAST, XU will come 140.63. Now, immediately do one thing, don't waste too much time. So, one small note, I should not tell, personal note, less is less, equal is equal, more means equal. Sorry, I will not explain further. Now, right here, therefore, your XU is less than XU max. Therefore, under reinforced section, so continue with the same value of XU. Just make a note. In case you get more than XU maximum, this XU cancelled, this already one example over. Consider XU equal to XU max, over. Now I am not telling. So, our XU is 140.63. Now see what to do. We got XU 140.63. One statement you are right here. See. I will remove this one now. I remove this one. See. From trial 1, we got XU equal to 140.63 millimeter, which differs from, see here, which differs from initially, okay, I'll write here now. Why that way? Systematically write. Therefore, here. Therefore, from trial 1, we got XU equal to 140.63 millimeter, which differs from initially considered value of XU for FSC calculation. That is how much? 272.55 millimeter. See, we started with 272.55, it came 140.63. Therefore, trial and error method to be continued, right? Trial and error is to be continued. Okay, I will continue now. Now do one thing, I am rubbing and changing the numerical. You should not do it. You should write everything once again. Trial 2. Now, this we will remove. This is not required. This will remove. Now, continue with XU equal to how much? Latest value. That is how much? 140.63 millimeter. 140.63 millimeter. That is latest value. Latest value. And get FSC and again get XU. Again get XU. Okay, start. Substituting. Now your epsilon SC will become, instead of 272.55, this number will change over to 140 points. You should write once again, remember, do not do like me. I am teaching, you are learning. Don't rub and write there. Once again you are right. The value will come 0.00286. Oh, sorry, what is this one? 226. 226. Okay, start. Now to find FSC for epsilon SC equal to 0.00226. Tor steel. Actually now statements are not required. Why? Only once you are write the statement. Second time, third time all, don't waste time writing epsilon like that. Nothing required. Now it's right. Okay. This is removed. This is also removed directly. Now these things are removed. What you can do? Now epsilon SC, which is more than epsilon SC PL. How much PL? 0.00174. Therefore, once again what? Therefore, curved part. Personal note, curved part. From figure 23A of IS code for epsilon SC calculated equal to 0.00226. We get FSC equal to, now do one thing. What I told, along the baseline, mark the point, go up and come this side. I think that value will lie between, where I noted down? Oh, I think I have not noted down what is the number. Okay. I require calculator. 1 minute. Because I directly wrote the answer. How much fraction I have not written? 1 minute. I'll get the calculator. Okay. CIS code. I noted the answer now. It will come. Where is it? 0.9. Actually, very near to 0.9. Okay. 0.9 times 90 times Fy by 1.15 equal to 0.90 into 500 by 1.15. Value will come. Remove this one now. 0.9 will come. Okay. 391.3. 391.3 Newton per mm square. Okay. Now, 1 minute. Make a note. If you refer to SP16, you will get, I noted down there, it will come 391.3. Make a note if you want. Suppose you refer SP16, you will get 391.3 if you refer. Now, okay, this is what? Not required. Okay, already over. I can save time now. Okay, now. This also is not required. Word 1. Okay, see, now. Therefore, what do you do? FSC. Now find XU for FSC equal to 391.3 Newton per mm square. Substituting this equation, everything same. This number will change to, you should not do it, 391.3. Okay, calculate. Your XU will come 146.2. See, it is playing slightly. 146.2. I will explain it later. From trial 1, okay, 146.2. Okay, valid. It is less than XU max. Leave it. Write a note here. Less than XU max, valid. From trial 1, not trial 1. From trial 2, we got XU, how much? 146.2. Which differs from, I don't know, what there? I think I am writing there, no? I am writing there. Okay. I am writing there. See, now, therefore, from trial 2, you should write once again. We got XU, how much? 146.2 0.20 millimeter, which differs from not precision, which are from value of xu from previous trial, that is trial 1. How much it is? That is how much previous value of xu? You can see here 140.63. 140.63 millimeter. You see, you took 140.63, it now changed over to 146.2. Therefore, trial and error, right? Note here. See, initially 272 severely dropped. Now slightly raised. Now see, difference is lesser now. Okay, start. Now trial 3. Trial 3 is with xu equal to fresh value 146.2 millimeter. Now I should not explain. Do this way, change the values. Now if you don't do anything, you are not fit for studying. 146.20, your strain will come. Idaitu 0.00230. Okay, do one thing now. Remember, it actually comes 0.02303, but we stop here. After zeros, only 2 decimal, 2 numbers sufficient. Therefore, 23. This is not considered 23. Okay. Now to find epsilon SC for FSC, for epsilon SC equal to 0.0023, which is more. Okay. Same figure for 0.0023. If you see the IS code, mark the strain, go there, it will almost come it comes slightly above 0.9, but below 0.91. So I will write 0.905 Fy. This is my judgment by 1.15. This you have to check it. Equal to 0.905 into 500 by 1.15 equal to 393.48 Newton per mm square. Okay. Make a note. If ಇದು ಬೇಡ, ಇದು ನನ್ನ ಪರ್ಸನಲ್ ನಂಬರ್, ಇದು ಮೈ ಪರ್ಸನಲ್ ನಂಬರ್. If you refer SP16, you will get a 393. So 0.4 error will come. Okay, now substituting xu equal to 393.48 Newton per mm square. Same thing here, 393.48. You should not do this way, write everything. Your xu will come 145.69. 145.69 millimeter, right here. Therefore, from trial 3, we got xu, how much? 145.69 millimeter, which slightly differs. Just for fun I told, slightly differs from previous value from trial 2 of how much? 146.2. Very not too much. Therefore, see 146.2, 145.69. Trial and error continued. Trial 4. Continue with xu equal to 145.69. 145.69. Substitute 145.69. Sorry, this is, see, too much neatness I am not going now. Why? Because I can't rub the board neatly and do everything. This will come 0.00. Once again 230, but this time it comes 0.022,988. But when you round up to this decimal, 0.002 number, 29 is there, it will become 3. Okay. Therefore, see, very, very happy. See, that 0.00 last time, see, 0.002303. Now 0.0022988. Because of this 988, this will become 3. Now see. Now stop now. Now you should stop actually. Tell why reason. Now you should not continue because see, 0.003. Okay. Or no. Write here answer. Now write. Oh, don't write O. Epsilon SC we got, that is 0.00230 from this trial is same as epsilon SC from previous trial. Therefore, FSC will repeat and hence XU also will repeat. Therefore, trial and error stop here. Now finally go for ultimate MR. Over. Finally go for ultimate MR. Just to make one note, one confirmation required here. See, before going to ultimate MR, one confirmation required. Lastly, confirm it. None of them required. See, now too much clean I am not going because it will take, already it's midnight now. I take some rest also. So, not bother too much about that dust actually. See, learning is more important, not this other thing. Therefore, confirmation. XU equal, first FSC. Your FSC equal to, same answer as last time. See, I wrote here, once again same, 393.48 Newton per mm square, and XU equal to 145.69 millimeter. 69 millimeter. Over. Now, one note you write here. See, just a note if you want. XU will depend XU. Using XU, you find epsilon SC. Using that, you find FSC. So, among these three, if any one repeats, other two will repeat. See, if XU changes, epsilon SC will change. If epsilon SC changes, FSC will change. If FSC changes, XU will change. Now, therefore, in this question, epsilon SC repeated. In some question, FSC will repeat. In some question, XU will repeat. So remember, XU, epsilon SC, and FSC. In these three, the moment one of them repeats, immediately, over. That's all. I read the final answer now. Okay. Now, find ultimate MR. Start. Over. Now over. 1 minute. Ultimate MR of given cross section mu. If you use the basic equation, it is 0.36 into FCK into B into XU into D minus 0.42 XU plus FSC into ASC into D minus D dash equal to 0.36 into FCK 30, B is 250, XU is 145.69 into bracket 592.5 minus 0.42 into XU 145.69 plus FSC 393.48 into 628.32 into 592.5 minus 50. Calculate, it will come 10 to the power 6 Newton millimeter. It will come 343.12. 343.12, that is 343.12 kilonewton meter. Or if you are going to IS code version, your mu equal to 0.36 into, I told I am writing formula, I never come to class by hearted, into, because when I write something, I know what I am writing, not by hearted equation. Okay, now see, this equation. Before substituting, find XU by D. XU 145.69 divided by 592.5. 0.2148, 0.2459. Little more accuracy. 2459. Correct answer. Let's check once again. 0.2459. Correct? Huh? 145.69 divided by 592.5. 0.2459. Okay, now substitute. Known, everything is known. You only substitute. Answer will come guaranteed 343.12 10 to the power 6 Newton millimeter or Kn meter, right? And close the question. Work out this question thoroughly. Little fast I did because it is a repetition. I am telling procedure for 6th or 7th time. This question, if you thoroughly work out, all the previous questions will be clear. Hope at least this is useful for you. No comments, nothing from your side. At least put some comments. If not clear, if I am of no use, tell that also, no problem.